Hey all, this video is solving systems of equations using substitution. Substitution is a method that we can use to solve systems of equations. To use substitutions, we first solve one of our equations for one variable. Think about turning an equation into slope-intercept form. Then we substitute that variable back into the other equation. So kind of like we have the graph, we have two equations. So let's say the first one is 2x plus 8y equals 16 for an example. And I want to solve for the variable y. If I want to solve for y, for slope-intercept form, we've done this a lot. Subtract 2x from both sides, negative 2x plus 16, and then divide both sides by 8. leave me with negative 1/4 x. 16 divided by 8 is plus 2. Now, I have my y. I have my new, that's what y equals. Y equals negative 1/4 x plus 2. So going back to the previous, this one right here, if I just retype this, 2x plus 8y equals 16, but I replace this y with my new y equals, that's going to substitute in a new equation. So this would become, let's get it even a different color. 2x plus 8, and then instead of y, I'm going to replace that with negative 1/4 x plus 2 equals 16. Kind of ran out of the room there. I would distribute here 2x plus, and then 8 times negative 1 is negative 8 divided by 4. It's going to be negative 2 plus 2 equals 16. Oh, I forgot the x here. X. 2 positive 2x and a negative 2x added together, those are going to cancel out. 8 times 2 is not 2, it's actually 16. Goodness gracious. So 16 equals 16. So this works. As you can see, I took an equation, solved for y, and then plugged it back in to make sure that it still worked. Make sure I got it right. That's kind of the method we're going to be using, substituting. Like when you go into a game for somebody else. If you're a soccer player and you sub into the game, someone comes out and you go in. Substitution. Before we get to an example, here's a procedure that you should write down for yourself. Solving substitution procedure. The first thing you do is solve for one of the variables in one equation. So oftentimes it'll be solving for y, like we do in slope-intercept form. We're kind of used to that, so that's a good place to start. The second thing we want to do is substitute for that variable in the other equation. Number 3, solve for the remaining variable, so we'd solve for x. And then 4, substitute the known variable for the unknown variable. This will make a lot more sense when we start using examples. Example 1, solve the system using substitution. Remember that solving is going to be a point. We did solving by graphing earlier, where we solved both for y, and then we put them into a graph, and we found that intersection point. Substitution is going to let us do it a different way. My top one here, x plus y equals 12. That's not too bad, right? I'm just going to subtract x from both sides. If I do that, I should get y equals x minus 12. I'm on fire today. It should be 12 minus x. Y equals 12 minus x. So that's good for this one. I have my y equals. But now I want to plug in this y into my secondary equation, my second equation there. And if I do that, it should look something like this, where this 12 minus x is going to replace the y right there. So from here, I should be able to solve for x. 2x plus 3 times 12 minus x in parentheses equals 31. If I work that out, I would distribute, and I would get 2x plus 36 minus 3x equals 31. Combine like terms, 2x and negative 3x should get negative x plus 36 equals 31. Subtract 36 from both sides. negative x equals negative 5, and x would equal 5. Okay, so I've got a lot of work in, some substituting, and I've solved for x. And even though I solved for x or for y up here, I can get even more specific now that I know the value of x. So let's take a look at that. Back. If x equals 5, I would have y equals 12 minus x. I would substitute in x here for 5. 12 minus 5, y would equal 7. I probably need to go back and just absolutely make certain that I feel good about this. So let's go back to this one and replace my x is 5, my ordered pair here, and 7. 2x plus 3y equals 31. So 2 times 5 plus 3 times 7 equals 31. 2 times 5 is 10, plus 3 times 7 is 21. That looks pretty good. 31 does equal 31. Let's actually look on a graph and even check again. Here, I have x plus y equals 12 and 2x plus 3y equals 31. And if I go click on the point 5, 7, that is definitely where they cross. So we're in a good spot there. Let's try another one. Solve the system using substitution. So kind of my frame of thought here, 7x plus 4y equals 18. If I solve for y, that's probably going to be some fractions. But down here I see 6x minus 3y equals 9. I'm probably going to get integers because they're all multiples of 3. Doesn't matter which one you pick. Having thoughts on it is good. When you see clues like that, it might be a little easier for you. Easier is usually better in math. So I'm going to do 6x minus 3y equals 9. If I subtract 6x from both sides, I'll get that. And if I divide by negative 3, that would leave me with y equals negative 6 divided by negative 3 is 2x minus 3. Y equals 2x minus 3. If I were to substitute that y into this equation, then I would only have x's, and I'd be able to solve from there. That would look something like this. 7x plus 4y equals 18 would become 7x plus 4 times 2x minus 3 would equal 18. Distribute, keep the 7x, plus 8x minus 4 times negative 3 is 12. Negative 12 equals 18. Combine like terms, 15x, and then add 12 to both sides equals 30. Divide both sides by 2, and x should equal 2. X should equal 2. Hopefully you're following along there. I got x equals 2. Now I know what my y equals, 2x minus 3. I can substitute my new x amount back into there. Substitution continues. Y equals 2x minus 3 would become y equals 2 times 2 minus 3. Let's use parentheses there. 4 minus 3, y would equal 1. So now I have an ordered pair of 2, 1. 2, 1. Now let's make sure that works with one of our first equations, just to be safe. Let's plug this back into 6x minus 3y equals 9. 6 times 2 minus 3 times 1. 6 times 2 is 12, minus 3 times 1 is 3, equals 9. Booyah. 9 does equal 9. Let's take a look at the Desmos here and see if we get the same thing here. So take those off, turn those on. That gets us at 2, 1. Wonderful. Cool. Lots of different ways you can verify for solving systems. Why don't you all head to Schoology and try it yourselves. Solve the system using substitution. And remember that you are all bright and shiny stars. Goodbye.